Bismillahirrahmanirrahim. Assalamu alaikum. Today we will discuss lab number 2. The title of the lab is to study the basic parts of the DC machines. Here we are having a small machine and we are having another machine of larger horsepower ratings. It can be seen here. Now, what are the basic parts of the DC machine? On the DC machine we are having two basic parts. One is known as the stator of the DC machine. This is the stator of the DC machine and this is the rotor of the DC machine. Stator is the static part of the DC machine and rotor is the rotating part of the DC machine. On the stator there lies the excitation system or the field system. On the rotor there lies the armature windings, which are the main windings, where voltage can be generated. In the case of the generator or in the case of the motor, we have to supply an external voltage to the armature part. In case of the motor, we have to supply voltages to both the field system, excitation system, and the armature windings. In the case of the generator, we have to supply excitation voltage, but we have to rotate this rotor by some external mean. Okay, coming to the basic parts. Now the outermost part, that is known as the yoke of the DC machines, and this yoke protect the DC machines, and similarly this yoke or frame is made of the magnetic material. It can provide a path for the flow of magnetic flux. For example, these are the field system. So this is the field system lies on the stator. So the stator encloses the excitation system. And the excitation system consists of the field core. This is the field core, this one. And this is the field windings. Field windings are made of the copper, where the field core is made of the magnetic material. And the field core is made of the magnetic material, and the field system is the field core is laminated. It is made of the iron sheets, so that's why this is laminated to reduce the eddy current losses. Okay, so there is on the stator there lies also there is a bearing to reduce the friction losses. So for example, this is the excitation system or the field system. If one of the if this is the one of the pole, north pole, and let's assume this is the south pole, when magnetic flux pass, it will pass through the rotor. Here will be the rotor will be inserted here, and it will be through the rotor, it will go to the south pole of this excitation system, and through this frame, iron frame, the magnetic flux will return to the north pole. So it can provide a return path for the flow of magnetic flux. Okay, coming to the armature part. So here this whole setup is the rotor, where this is here on the rotor lies the armature windings. So these are armature windings. And these armature windings are enclosed inside the segments. These are the segments, and these are the segments, and this is the armature core. This is the armature core, and these are the armature windings, right? And the armature windings are connected to the switch. We are having the commutator. This is the commutator, and these are the segments of the commutator. This is the commutator. What is the purpose of the commutator? Commutator in the case of the DC generator can convert AC to the DC. And there is a pair of the carbon brushes as well. These are the carbon brushes. This is the carbon brush, this one, and this one is the carbon brushes. So these carbon brushes are sliding against the rotating armature. So this is the armature part, or this is the rotor part. Similarly, We can see here, this sign shows the armature of the DC machines, and A1 and A2 shows that the windings are connected by means of the carbon brushes to the A1 terminal and A2 terminal. So here, this is a relatively large horsepower machine. This is the field system, this is the field core, and these are the field windings. Where this is the armature of the big machine, where this is the commutator part, these are the commutator segments, these are the armature windings, and this is the armature core. And this armature core is a bit skewed to reduce the magnetic hum. Here you can see here, this is the armature core, where this armature core is without any windings, and you can see here these are the laminations where the armature core is laminated to reduce the eddy current losses, and this is the commutator of the DC machine. So thank you.